Stuart here. Today we're going to give a quick overview of risk management for developers and architects and technical folks. We're just going to buzz through to the essentials at uni. This is typically a 3-unit course all by itself with labs and practice drills and the ability to set your peers on fire. So that's always fun. We're going to focus on just the bits that I want you to anchor in your head, and then hopefully this will inspire you to go take a course or something. Before we get to that, there's always the existential question of, why am I watching this video? Why you should care about this video is, even as a very junior developer, you have to start thinking about risk. Because if you've watched my video series on how to be good at your job, and at different jobs, developer, senior developer, or dev lead, architect, whatever, talk about risk and tempo a lot. But basically, knowing how to deal with risk is an essential survival skill. And our want in life is to survive to code another day. I'm a developer because I like to code. Sadly, that involves being in projects because that's where the money is. And if I had an enormous pile of cash, I'd still code, but I'd code something different than what they want me to code, because they want me to code the things that will make them cash, and they'll give me a little cash to do that. So that's sort of the ecosystem there. Forget that essentially for most companies or organizations, government organizations or whatever, they don't exist for IT. IT is a necessary evil. They can't function without it, but if there was a genie with a lamp and 3 wishes, they'd wish it away probably right after taxes and regulation. IT would be third on the list of things they'd wish away. So this is about survival. And I'm going to do a series of videos on survival things. You could argue that many of my previous videos have been about survival things. But here's some survival tactics in summary from previous videos. Don't be afraid to say I don't know, but a professional always follows it up with, but I'll find out. Know what you can fix and what you can't? Learn critical thinking. If you didn't take a critical thinking course at uni, you don't know how to think critically, probably. You may have a natural ability or instinct for it, but you haven't formalized it. So you really should take a critical thinking class, particularly if you ascribe to any kind of management, team lead, architect, whatever. And you'll find that eventually it'll become second nature to you. It will help you in a, detective solving crime sort of way, get right to what the problem is by helping you get rid of all the things that are not relevant to the problem at hand. And that's really about what root cause analysis is. And we'll talk about a little more about why that's important later. It's astounding how many developers are completely unable to state a problem, to decompose the problem into pieces, and to do estimation. All good skills, some of them covered in other videos. But if you can't phrase a problem in a quick, clean way, and then offer multiple alternatives, or if it's one of those things like, what do you want me to do now about that? Ask directly for guidance or action, you're really going to suffer compared to your peers that can. Probably the second or third most common thing that I coach on is that very bullet, which is how to phrase a problem quickly and cleanly, and then, how to break up that email or that memo or that DM or whatever, but have a package that's ready to go. In the architecture sections, in the DDD sections, we talk about patterns and anti-patterns, and you should know patterns at all levels of granularity, from something as crisp and small as a singleton in code, all the way up to the concept of observability, which we're going to touch on in here. Know when to talk and know when to not. Probably the hardest skill I had to learn over my last 40 years plus. There are just some moments in certain meetings where your best bet is to fade into the woodwork and let you and them fight. Just let them work it out. And then later on, if you want to sidle over to your boss and go, so that went well. Didn't hear any solutions coming out of that meeting. Heard a lot of blame. Saw the construction of several suicidal ideations disguised as, remediation alternatives. What do you actually want me to do? And then there are moments when people are so delusional in a meeting that the converse is true. Junior or not, senior or not, you need to raise your hand and say, I'm sorry, we seem to have strayed from the path of critical thinking. And the actual question, not the questions that are being asked, but the actual question, the baseline question, the most important question is blah, blah, blah. Next thing, and I keep talking about this in different presentations. There's this guy, George T. Doran. And in a happy coincidence, he took all of the stuff that I've been struggling to articulate about how to do technical writing of any kind that is relevant to solutioning anything. And he came up with an acronym that's not only easy to remember, but where every element in the acronym has weight and usefulness and utility. And it's the SMART algorithm. And I call it an algorithm as much as an acronym because if we are writing anything, if we're writing a user story, or we'll see later if we're writing a risk, that the algorithm is about your execution of SMART. So as you go along, were you specific? Did you have measures? And for risk management, measures are super, super important. Actionable, right? Remediations are actionable. Detections are actionable. Relevant. Like, if the thing isn't relevant, why are we writing it? And of course, time bound. We need to be able to bracket things in time. And we'll talk about all of those in subtle ways as we go through our risk management. So let's clear up some vocabulary, because as I read the interweb, I notice that people are commingling risk and incident, and that is not correct. A risk is something that could happen. An incident is something that did happen. Could, did. When we're doing a project and we're trying to cover our bases and be good technologists, right? We want to enumerate risks. And then as we go through the implementation of our program, not just the code, but all of it, we want to be keeping a weather eye out for when those risks have turned into incidents. And sometimes incidents happen without an associated risk. And now we got to go add a new risk. And an incident is a risk that has had a 100% chance of happening. Been there, been up all night with that. So a risk is potential and an incident is actual. Severity is really important. And I have seen over the years some truly mental severity charts. I saw one with 9 degrees of very subtle distinctions between one and another, and sat through meetings where we spent 20 minutes discussing whether something is a 6 or a 7. Nope. That's not how real humans do it in the real world who really, really get things done. There's 2, high and low. And they're both tied to service level agreement, SLA. So if the problem needs to be fixed in minutes or hours, like sub-day, then it's high severity. If the problem needs to be fixed in days, weeks, it's low severity. Somebody has resigned. Somebody has said, come down from the mountain with a new set of stone tablets and said, requirements are changing. We don't have to respond to those in hours or minutes. Production's down, and there are 20,000 users around the world who can't do their job. That's high severity. So if you're on a project and they're talking about these really beautiful, ornate severity charts for risk management, you can have different severities for bugs and for other stuff. But for risk management, there's high and there's low. Minutes and hours versus days or weeks. Somebody resigns, we may have a couple of weeks to recruit a replacement. And sometimes low severity incidents are often referred to as problems. Don't treat them any differently other than procedurally. We'll show you how to do the procedural differences. But they're still incidents. So the fewer vocabulary words you force your program to understand, then the better off you are. And so not only for sanity's sake, but for clarity, incident severity is probably the most important thing. And incident severity and bug severity are not the same thing, right? Incident severity is about service level agreements. And again, high, minutes, hours. Low, days, weeks. Ultimately, whoever your project sponsor is, who's ever writing the checks, gets to decide what the severity of something is. Or their proxy. They may very well have nominated someone. And you know, Susan's our big chief boss, and she has Sadak, and Sadak is our, project risk management officer. And so he's going to call it. And he's going to figure out how to call it by having some input in the forms of metrics, because he's had risk management training. He took that 3-unit course or that online course. And so he really knows about it. He knows how to calculate the costs of incidents. He knows how to estimate risks on likely project schedule and cost, right? Because he's had the big course. This is the intro. So that's important. So there's a risk incident cycle, and these vary, right? When you go take your risk management course, they may have a completely different wheel. But this is the simplest wheel I could find across the literature. It's actually a hybrid. This is actually my custom wheel that has all the things I think are indispensable, and other organizations or other strategies may add pie wedgies and divide them differently. But I figure, again, 5's a number most people can remember, and we can cope with 5, and 5 fits on a PowerPoint slide. Wait, that wasn't a good reason. But it is a measure of simplicity. Being simple doesn't mean unsophisticated, by the way. It just means simple. So where do we start? We start by identifying risks and documenting them. And so at the beginning of a project, most organizations will have a document, which is a template for your project based on the project type. And it will have a whole bunch of the obvious, seen these on other projects, need to think about these for your project's thing. And, a good one will have 50 to 100 of those. And I hear you going, wow, 100 risks. Well, they're in different categories. We'll talk about that. So some of them are in the realm of software engineers, right? Us. And some of them are in the realm of OPP, other people's problems. So project managers or, staffing people, whatever. And then you go through that list with your team and you go, well, that's not a concern. We're going to nuke that one out of there. And then we'll go through, and as we go along, we're going to continuously update that list of risks. We're going to identify them. We're going to document them. The next thing we need to do is, what would trigger the risk to become an incident? And it may be a bunch of different stuff, or it may just be one thing. If the risk was triggered to turn into an incident, how do we know that happened? Some of them are pretty obvious. The entire QA group quit. Aha! That's now an incident, because we need to replace the QA group. And then we need to ask why they all quit at once. And we need to think about other things too. But that's a different video. And then what are our response options? So let me be clear. Response and remediation are connected but not identical. Our response is to reach for a playbook of some kind and a procedure and follow it. And there may be different procedures, even for the same risk, based on how we detected it or what triggered it. Or there may just be one. The response is to identify the procedure we're going to follow. And then in that procedure, there will be remediations. And of course, we need to, for every remediation, we need to have testability. We need to know if it worked. In some cases, like the entire QA department quit, the remediation is we go hire a new QA department, but is the new QA department going to be ready to start QAing things? And if so, when? And after how much time has passed do we conclude that, in fact, that didn't work? If production is down, production comes back up, or looks like it comes back up. It's called pseudo-success or phantom success or delusional success. Generally, delusional success involves an aircraft carrier and a really big banner, but so you have to be able to validate through testing of some kind. And testing doesn't always mean like automated tests, like us developers think of. Just how do you know your remediation has resolved the incident? And then last but not least, we need to do a post-mortem and say, like, how do we keep that from happening in the future? Sometimes we can't. Some incidents are, in our risk register, or we have a risk in our risk register that says nuclear weapons obliterate data center east. Probably not a lot we could have done to prevent that. So we make a note that says, under the prevention part of the post-apocalypse form, we say, data center gone and radioactive, occupied by zombies, prevention strategy, NA. And then you may want to look back at what happened and go, do we need to update our risk? Do we need to update our triggers and detection? Do we need to update our response plan? Do we need to update our remediations? It's a continuous cycle because quality never stops and projects never end. So what's part of a well-written risk? Well, the biggies before. Title. I cannot tell you how important it is to have a convention for titles in the risk register and to actually follow it. Because if you have, even with filtering on, right? So you get some piece of software, even as simple as an Excel spreadsheet, and you've got filters based on, categorization, which we'll talk about in a minute. But just have a convention in the, title convention that at a glance tells people, is this a high risk or is this a low risk? Is this a technical risk, a personnel risk, or whatever risk? And then what specifically is it in as few words as possible? Titles do not have to be full sentences if there's not enough room. If there is enough room, please do. You want a description. And here's where our friend SMART comes in. When we're reading our description, which is, broken down into the parts of the wheel, we got to make sure that every one of those things is SMART. We have categorization metadata like dates and risk areas. There are 5 big ones, but your project may have more different ones. You may break some of them up into smaller pieces. Doesn't matter. At the end of the day, if you look across the whole realm of project management, there are 5 kind of big risk puddles, and then you can dice, slice, and julienne. You need to have a score for the risk, which is about likelihood and severity. Notice this is a slightly different severity than high and low, although this will contribute to that severity. But again, severity of risks is tied to the service level agreement. You cannot have a well-documented risk without service level agreement. And then you need to identify the org units. I know it's tempting for simplicity to put people's names in there. But if you have a project with 100 people and you have a 5% cycle churn, 5% turnover, how long does it take before a significant number of those human names, as opposed to org names, in the risk register are no longer pointing at actual people? And then you got to go back and ask, well, what the heck did who was Jane Brown and what org was she with? And of course, that stuff's all missing now because they got yarded out of the people system. Org units are almost always better if the org unit is linkable off to the org unit, and then you see who are the people in that org unit. Here's I took my last 20 projects and I just did a line count on the risk register by category. And then I had to go through and, they didn't have this category or they called it something else. It took me a while. But this is a pie chart I ended up with. Your mileage may vary, but I think it's important to understand that technology risk is incredibly small compared to everything that is driven by people on your own project. We have met the enemy, and they are us. Technology risks are things that come from the outside, like from vendors. Turns out there's a major bug in the operating system, or the library you're using actually is shipping all of your data to North Korea, that sort of stuff. Surprisingly small number of risks in the risk register come from that. There's always kind of placeholder risk for technology called production goes down. And the trigger is production is down. How do we know? Oh, you'll know. I hope. If you don't know, that's another question. We're going to talk about that later. You should know. But notice that the things that really are going to make us miserable are scope, schedule, and people. People turnover, particularly, is brutally hard on projects, especially the higher ranking they go. Not because they're better, but because they were responsible for stuff that now someone else has to learn and give guidance about. You lose the business analyst that knew everything about accounts payable with someone who may have some general accounting knowledge, and that person's going to have a heck of an uphill climb. And in the meantime, your developers are going to be going, qua? And that in turn will turn that people problem into a scheduling problem. And then we may have to de-scope things, which turns it into a scoping problem. See where I'm going here? And the reverse is also true. We added a bunch of scope that blows out our schedule, which means we need more people if we're going to stay with the same schedule. But as been famously pointed out, if it takes one lady 9 months to have a baby, adding a second lady to the problem does not have the duration. There's a place at which adding people makes your project take longer because they have to onboard. In some organizations, just getting them a laptop and a login is a 30-day deal. Let's make it clear. Accountability is the number one place where projects go into the dumpster fire and they don't come out. If a single human isn't it for something, they're not responsible for doing it, they're responsible for making sure it gets done, which is why on most projects I insist on using a RACI matrix, RACI, which stands for responsible, accountable, consulted, and involved. If it is a risk is not owned by a single OU, and that means at the top of that OU's pyramid is a person, or maybe their deputy, right? We talked about the deputy before, right? Deputy. Then it's not owned by anyone, and risks that are not owned by anyone are not okay, because it means that when the risk turns into an incident, there won't be anyone to give us guidance on what the absolute definition of fixed means, and there won't be anyone to point to and say, go run this incident. This is your risk. Run the incident. Categorize a response. Drive the remediation. Validate the remediation. Figure out how we can prevent it from happening in the future. And you are responsible for writing the post-incident report in which all that stuff is summarized. Man, I hate this. I've been on half the projects I've been on. Almost no one could look at the risk register because it was confidential. Look, you either trust the people on your project or you don't. If you want to restrict it to just the people on the project, I can't really argue with that. But you really need to make it so that every dev, every QA, every BA, every PM, every product owner, everyone knows where the risk register is, right? If you have a project portal, that should probably be the third bullet down on that list of handy links and places to go. Everybody should have contribution access. And so where do we put it? Well, if you've got ADO or Jira, right, there are plugins for that, and they work great, and that's the best place to put it. Because a person with one watch knows what time it is, and a person with two is never sure. E.g., if you have a million different pieces of software and systems that kind of quasi-sort of keep in sync with each other, you'll never know what time it is. So, one throat to choke, ideally. If you're a Microsoft shop, you'll have SharePoint, and so you could use a form or a spreadsheet. And a form is just a thing over the top of a spreadsheet. But they work great. Low severity incident management. The entire QA team quit. How do we know? You are the unhappy manager who just got their resignation email. So low severity incidents are characterized by an asynchronous process, which means that because their resolution time needs to be in days or weeks, you can sit down and, plot a process and execute it. So you write a memo and you explain what's going on and you explain what to do about it, and then you follow up. It's a rare organization that can avoid one or more meetings. If you can avoid meetings, you should avoid meetings. And then just make sure that somebody knows it's their job to make sure this gets done. That's really, really, really important. And once you've written the obligatory post-incident report, make sure that it gets added, that link gets added to the risk register. And again, who should be allowed to read these? Everyone. So please don't put, confidential is okay, don't put secret stuff in the post-incident report. High severity incident management. Step 1, take deep cleansing breath. Step 2, make an incident bridge. Have a conference call. And if you have an automated system, that'll do the second one for you. We've got a system that interfaces with Microsoft Teams, and it actually makes a new Teams channel, and pinned to the top of the channel is the dial into the incident bridge. And then the system will add everyone who needs to be part of the channel into the channel and send them a notification. And we'll show you how that could work at the end of the presentation. First thing, have the proofs ready. How do we know the risk is now an incident? At 03:45 a.m., our Pacific Rim customers said that they were unable to navigate to the website. Proof. Navigate to the website, you get a 404 or a 500 or whatever. The whole site's down. Other things have other things. But have proofs ready. Because the first thing that grumpy people are going to want to know when you pull them away from their life and or wake them up is, how do you know this is actually an incident? And why can't it wait till I'm, awake and filled with caffeine? So have proofs ready. I know. Doesn't sound like a big deal, but it speaks volumes about your professionalism if you have it. Have links to the response remediation plan. Post it on the bridge. Identify the incident manager. It may not be you. Probably shouldn't be you. Probably should be somebody in production support. But a human being is going to be incident manager. And if there's shift changes or whatever at the shift change, the old incident manager says, as of right now, I, Jamel Warner, am transferring incident management command to Sundara Parmava. Big old message in the bridge. The incident manager needs to keep notes, lots and lots of notes. And they are responsible for wrangling the resulting cat rodeo. Keep people focused on bringing the site or whatever back up. Once it's up, they don't get to go. You need to start filling out how the heck did this happen? How do we detect it's going to happen before it actually happens better? This can be the next day. That's okay. You don't have to do it at 4:45 a.m., et cetera, right? They're responsible. The incident manager is responsible for closing the loop on high severity incidents. We're developers. This is for developers. I grant you, I'm focusing on the 5% here, but I'm focusing on the 5% that you can do something about. Remember our survival guide? What was bullet number 2? Know what you can do something about and what you can't. Can't do much about people quitting. Or about tsunamis, but you can do something about whether or not your system is alive-o. There are good tools for every single stack and technology base out there. So just as an example, I work in Azure and I write code. My code knows how to send messages to App Insights. App Insights are aggregated into monitors with triggers, and Sentinel is monitoring traffic on my network and is listening to all the different security appliances. And I roll all those things up and send them somewhere. And again, I'll show you that one in a minute. But the important thing isn't the tool choice as much as making sure they get set up properly, and that as new things are provisioned and automated, they automatically fall into the scope of your tool. They're added to the tool's attention. And at pretty frequent intervals, you should probably check that the profiles for each resource type or deployable type are relevant, and that you're getting your thresholds by which you're saying, if the CPU on the SQL server is over 90% for longer than 5 minutes, that's probably a problem. I should generate an alert about that. But you need to balance that, right? You need to it's going to take a couple of cycles. And every time they update the version of the tooling, or you start using it differently, and that's really important, you should go back and check that. And typically, this is right on the place where DevSecOps happens, right? So developers, security professionals, and ops professionals come together, and they look at what they've got once a cycle or so, and they go, do we need to tweak any of these? And sometimes they're just getting a snot load of a particular alert type, and they say, okay, we're going to call an audible, we're going to have a quick meeting, and we're going to say, okay, does it make sense to tweak this, or is this actually an early warning sign that we need to, change our topology, or upscale, or scale out, or whatever? Like, we need to remediate this before it becomes an incident, while it's still a risk and we can manage it. Because you don't manage incidents as much as effectively guide them to conclusion, which is, I suppose, technically managing. Yes, I know. But I'm just saying prevention is way better than an incident. So if you don't do these things, prevention's not really an option. If you don't do any monitoring, if you have no observability, remember we talked about that earlier, all you ever have is incidents. You're not really managing risk. And then you've got to test. You really do. I don't generally test in production. I generally have a pre-production environment, and then I simulate different things that could go horribly wrong. And I make sure that the alerts are flowing to somewhere someone has to pay attention to. Here's how this could work. I'm just going to pick on one of the most used third-party tools for this, which is PagerDuty. I like PagerDuty. I don't love PagerDuty. It's hard to love something that wakes you up at 2:45. Yeah, come on. But I like it. But there's lots of tools. Other tools may vary. But this is the one I'm going to talk about. So the yellow box, that's our stuff, right? Monitoring triggers and detection tools. So in Azure, again, that would be App Insights. That would be Monitor. That would be Sentinel. And maybe other things poured into your mix. But the point is, their one and only job is to decide if something is bad. If something is bad, it is worthy of an alert. And then you send it to the thing that coordinates the human response to alerts. And in this case, we're using PagerDuty. And you want to make sure that your ticketing system from support is also feeding this. You want one mechanism. So again, you've got, people online or on the phone or coming to the help desk counter with a chainsaw. And then, that gets entered in the ticketing system. And the ticketing system is feeding streams of alerts to PagerDuty or whatever. And PagerDuty is deciding whether or not it is all in the aggregate incident worthy. And if it is, it creates an incident, typically writing back to the ticket system, which is why those arrows, by the way, are double folded, because you can also have it write back to, for example, Azure. And then it activates the notification process. So what we talked about before for high incidents, which is that it will go through and create a ticket, and it will create a bridge, and it will start notifying people to come onto the bridge by sending them the information about the bridge and an incident summary that it got from the ticket or it got from your alerts for monitoring. And then as we go along, if we have a system like this, the incident managers, where are they putting their notes? They're putting their notes into the ticketing system that goes along with that incident. And this is a pretty healthy thing. But if any of these parts aren't functional, then it all goes to poo. For low priority incidents, like there's one part of our website that is unfortunately really hard to use. And we get that feedback through the support team. And they create a ticket. That's going to be a what? That's going to be a low severity incident. And we'll implement the asynchronous system. And what PagerDuty will do is it will send an email because it goes, oh, this is an incident, but it's a low severity incident. And it will have a link to the ticket in the ticketing system. And it will have, links to other things in it. And then we'll start the low priority process. So that's how that works. Super rushed overview. Please do take a real course in this. And I hope you found it helpful. Thank you for your kind attention.